Hello everyone. Last class we discussed about the theories of light. We discussed about corpuscular theory, discussed about wave theory of light, and also electromagnetic theory of light, and finally quantum theory of light. Today we will discuss about in Unit 1 nature of light and scattering, dual nature of electromagnetic radiation. Dual nature means both particle nature and wavic nature of electromagnetic radiation. We'll try to prove it. So before that, we all know about electromagnetic spectrum consisting of various regions like seven regions. We know that if frequency wise if we tell or wavelength wise you can tell it, like we know the frequency and wavelength are inversely proportional. So increasing order if we tell about the radio frequencies, then microwave, then infrared, visible, ultraviolet, X-rays, and the highest frequencies gamma rays. Similarly, lowest wavelength, if it is shorter wavelength, if you can tell, then that is gamma rays, and the longer wavelength is radio waves. And we know the relationship is c is equal to f lambda, where c the speed of light, f is frequency, and lambda is the wavelength. So we can also find out the energy if we know the frequency. If we multiply with Planck's constant h, then we can also find out the energy. So if we will try to tell that whether this is a particle nature or this is a wave nature, how we can tell it? Particle nature means it has certain mass, it has certain velocity. If momentum will be there, mass will be there, kinetic energy will be there, then you can say that is a particle nature. And wave nature, like amplitude will be there, wavelength will be there, frequency will be there, then you can see that is wave nature. Like here electromagnetic spectrum, you can see the frequency, wavelength. So that is surely you can say that wavic nature, you can show wavic nature. So generally we will prove that this electromagnetic radiation includes the light. That is, electromagnetic radiation. Light is a form of, as you can understand that from the early stage, we understand that light is a form of energy. Later, we understand it's a form of also. It is also a form of electromagnetic radiation. Sorry. Then it exhibits both dual nature, particle, and wavic nature. Depending on the specific phenomenon, we try to understand this one. So now this wave nature we can understand how, like if we will find some interference means two or more waves, like when combined, then either constructive interference or destructive interference will occur. So then we can say that wavic nature. Or in diffraction also, bending of waves due to the obstruction or any obstacle will occur, then or any narrow opening, then bending of light, that diffraction or electromagnetic spectrum. Here we can see that only wavelength and frequencies, that also wavic nature you can explain. Particle nature, that is photoelectric effect. So photoelectric effect, before I will go to photoelectric effect, we all know about, if I will take like some, we told that some mass, like if I take a body, here you can see mass m1. Suppose we take a body of mass m1, and that is moving one, means it has certain kinetic energy and certain momentum. Another stationary body I took. So if I will push this m1, this body, what will happen? It will collide, then the body move certain distance. then a stationary body moves or displaces from its original position. Means what exactly happened? Why it moves? Because it transfers its kinetic energy and momentum. So means if it transfers kinetic energy and momentum means that is your particle nature. So this type of nature we can understand also in photoelectric effect. So photoelectric effect, when light incident on a metal surface, you can see metal surface, electrons will be there on the metal surface. And when light with high energy, a photon of energy h nu, if bombard on this metal surface, then electrons are ejected out. That is nothing but your photoelectric nature, which is proves about the particle nature. And wavic nature, I already told that if interference, in case of interference or diffraction or electromagnetic spectrum. So both now we try to prove it on electromagnetic radiation. So electromagnetic in radiation, like particle nature, wavic nature, we can understand somehow about this, the regions, about that frequency wavelength. We know that about the gamma rays or X rays or radio waves, all high frequency and wavelengths. We can say that wavic nature. So particle nature to prove it means if we can able to find out the kinetic energy and momentum of electromagnetic spectrum or electromagnetic radiation or waves, then we can prove this. So our aim is to try to find out energy and momentum of electromagnetic radiation or electromagnetic waves. So now we all know that capacitor and inductor. What do you mean by capacitor? Capacitor means it stores some energy. This energy in which form? Usually in electrical energy. So in the form of electrical energy, that is capacitor in a capacitor. In an inductor, that is also a storage device which store the energy in the form of magnetic. Magnetic energy usually stored in the form of magnetic energy. Magnetic. So now electromagnetic waves, if we consider, it has both electric component and magnetic field component. Electric field component, it means electric energy and magnetic energy will be there. So we have to find out the energy density of both for electric field and magnetic field. So means how much energy density find out means energy stored per into volume, that way to find out. So let's find out first in case of electrical components, electric field component. So energy stored in a capacitor, that is electrical energy, means in capacitor. So if you find out, you all know E is equal to half CV square. So then you know that C is epsilon naught A upon D, and E you know that is nothing but your V upon D. So that energy density, which I find out, the energy density means the stored per unit volume. So here you can see it. So if I find out energy density UE, if I represent, then energy stored is this one upon energy density volume. So we will find out epsilon naught E square upon 2 if we try to find out. So per unit volume, volume means we know that length, breadth and height. Volume are here. Area, area we already know that A, we can consider A into thickness D. So A into D. So if we put here, you can see now half CV square. So here half CV square, C is epsilon naught A. So now half of epsilon naught A upon D into B square. B square is nothing but your, here you can see now B square is nothing but your E square and D square, and on the opponent volume, that is area into thickness, so A into D. So now after cancellation, we will get epsilon naught E square upon 2. Sorry. Similarly, if for an inductor, if you try to find out E is equal to half Li square energy stored in an inductor. So L we know already for a toroid case, for a solenoid we already calculate, we already know that one. So L is equal to mu naught n square AI and B is equal to mu naught Ni. So energy density in magnetic field, if we try to put these things like energy per into energy stored per into volume. Similarly here also A into thickness L will take it. So now we will get it B square upon 2 mu naught. So if anyone facing problem here, how we got this one? B square upon, just I substitute here. E half Li square, L I put these values and I put these values, and then but just we substitute it, we will get this one. So now energy stored per unit volume in electromagnetic field. So we just add these two electrical components in electric field component and magnetic field component. So I can write this one. Now for monochromatic plane wave, we know B is equal to E upon C. And we all know that C is nothing but is equal 1 upon under root mu naught epsilon naught, or C square I can write 1 upon mu naught epsilon naught. So if we can put those values, we can get U is equal to, you can see now I will get epsilon naught E square. So what did it suggest? You can see both are same. So means here electric field and magnetic field contributes equal. So now if we try to find out energy flux density, if we try to find out, because our final goal is here energy as well as momentum we try to find out. So now we know that any electric field, if we try to write down in cos component, we know that E is equal to E naught cos of kx minus omega t plus delta, and U is equal to epsilon naught E square. So I can write E square, that is here I can write it E naught is, you can see the amplitude. So epsilon naught E square cos square kx minus omega t plus delta. So Poynting theorem, we know according to Poynting theorem, energy flux density, that is S, is equal to cross product of electric field and magnetic field intensity, or you can write half 1 upon mu naught E cross B magnetic field. So now if we do the cross product, suppose x, y, z, three coordinates in coordinate system, x axis, suppose unit vector is x cap, y axis unit vector is y cap, z axis unit vector is z cap. Then x cross x or y cross y or z cross z is equal to 0, because we know that a cross b is equal to ab sin theta n cap. Similarly, x cross y if we do, then we will get j cap. We will get k cap, z cap or g cap. Or y cross g if we do, then we'll get x cap. So similar way here, I just try to write kx for electric field component. So 1 upon mu naught E naught cos of, sorry, kx minus omega t plus till cross 1 upon c E naught cos of, sorry, y component ky minus omega t plus till. So now if we x cross y will do, we'll definitely get the z under z axis, or g cap or z cap, whatever pronunciation will be there. So we can write z cap. So s I can directly write e square upon mu naught c g cap, and c square we know 1 upon mu naught epsilon naught. So we can write here energy flux density S is equal to C U G cap. So what we can get it here, you can see now energy flux density is nothing but your energy density times velocity of waves. So C, velocity of waves, energy density is U. So now we can understand that electromagnetic field carry energy. Not only carry energy but also carry momentum, because we know that relationship P is equal to energy flux density upon C square. So we can directly find out the momentum. So momentum is U upon C into G cap. So you can understand here electromagnetic spectrum both has momentum and energy. So we prove that dual nature of electromagnetic waves. And if we try to find out average momentum or average energy density or average energy flux density, then average we can take it. We know that average, this symbol is average symbol, so average of energy density. So half of that one we can take it, half of this. Similarly, average energy flux density, half of this one, and average momentum we can write out, or you can tell also now this average power. Average power per unit area, if we try to find out, that gives you intensity. Intensity also you can able to find out. So I is that is average power per unit area. So we can find out also intensity. So this is all about dual nature of electromagnetic radiation or electromagnetic waves. So next we will try to find out definition and properties of wavefront. So what is wavefront? Different types of wavefronts, and what are the properties of wavefront? All will detail we'll discuss.